All right, let's warm up. Reminder, well, first of all, hey, Algebra 2, we are in Chapter 4, Section 7. Our warm-up, it's not time for you to skip. It's time for me to remind you of some skills you've learned in the past that we need for this lesson. So, let's warm up. Write an equation in slope-intercept form for the line through 2, 5, and 6, -3. This is an Algebra 1 skill. Slope-intercept form. Okay, y equals mx plus b. M is the slope. M is change in y, so subtract the y's over change in x. So I have -8 over 6 minus 2 is 4, -2. So that gives us y equals -2x plus b. B is the y-intercept. It's where your line crosses the y-axis. It's where x is 0 when your line crosses the y-axis. This right here, these 2 points are on this line that have this slope. So we can plug in, oh, for goodness sakes, that was a huge eraser. We can plug in one of these 2 values for x and y and solve for b. So we're going to do 2, 5. So xy, 5 equals -2 times x plus b. 5 equals -4 plus b. Add 4 to both sides. B equals 9. So now I have my equation. Y equals -2x plus 9. All right, there we go. That's for this problem, right? All right, we're going to do it again. This problem says write an equation in point-slope form for the line through those 2 points. Point-slope form looks like this. Y minus y1 equals m x minus x1. It's actually much easier. We still have to find m. So the values that we are going to input, we need to input those 3. So m is change in y, so subtract the y's. Doesn't matter what order you subtract them in, just has to be consistent. Over 5 minus 2, so 5.22 minus 4.53 divided by 5 minus 2 is 3. That gives me 0.23. So I'm going to pick that one. Doesn't matter why. We're going to have y minus 4.53 equals m times x minus 2. I could also say y minus 5.22 equals m x minus 5. Okay, another thing, what is the value of y if the point 10, y is on the line? So here we have a line, has a, if I did this, it'd have a y-intercept of 2.4 and a slope that increases. Okay, this line is on that, or this point is on that line. Somewhere over here we have 10, hits the line, and we could read y. So I could graph it, but that's silly. I'm just going to plug in the values and get the results. Okay, replace x with 10. That gives me 58. Plus 2.4 is 60.4. Easy peasy, right? All right, so let's get into our new lesson. Write an exponential function, y equals ab to the x, whose graph passes through those 2 points. So first of all, we're going to substitute the coordinates of the 2 given points into y equals a b to the x. So we have the values. Let's do the first one. xy, I have 12 equals a b to the first power. Then I have 108 equals a b to the third power, right? So let's solve this equation for a. A equals 12 over b. I could say b to the first power, but that's silly. I don't have to do that. So now I'm going to take what I solved for in the first equation and substitute it into the second equation. So I have 108 equals, instead of a, I'm going to write 12 over b, b to the third power. Okay, now I can solve for b. So 108 equals 12b cubed over b, or 12b squared. Divide both sides by 12. I have b squared equals 9. B equals 3, right? That's pretty cool. It actually equals plus or minus 3, but we're going for the positive one because b has to be greater than 0. So we're going to go back up here and say, all right, we know b is 3. Oops, see, I said 3. Now we know a is 4, so we're done. Y equals 4, which is a, 3, which is b to the x. Nice work. Right. Other stuff we can do. Transforming exponential data. A set of more than 2 points, x, y, fits an exponential pattern if and only if the set of transformed points, x log y, fits a linear pattern. Okay, so a set of more than 2 points, x, y, fits an exponential pattern if and only if the set of transformed points, x log y, fits a linear pattern. So xy is going to look exponential. X log y is going to look linear. I know, it's backwards. Okay, if we have 2 points xy and it looks like this, the graph is exponential. If we have 2 points x log y and it looks like this, the graph is a line. Whew, let's look at it. All right, a store sells motor scooters. The table shows the number y of scooters sold during the xth year that the store has been open. So I've got values, x, y values. Draw a scatter plot of the data pairs x log y, natural log y. Is an exponential model a good fit for the original data pairs x, y? Find an exponential model for the original data. All right. Right, I'm going to show you guys something to do on your calculator. So today I'm really going to know who's watching the video and who's not. So follow along, let me know if you need help in class. This is going to be a tad bit tedious, but I'd actually ask you to get your calculator out and follow along. First thing we need to do is, in your calculator, you've got all the x data and all the y data. 1, 2, 3, 4, 5, 6, 7. This is on your handout. All right, I need you to go to the Stat button on your calculator and edit. I want you to put all of the x data into L1 and all the y data into L2, and it's going to look a little like this. All right, y'all see that? The next thing I would like you to do is find the L1 button on your calculator. It's second number 1, but you need to, oh gosh, didn't mean to do that, sorry. You need to do L1, and then the store button, hold on, scratch that. We're actually going to take the log of, I'll do it, the log, yep, of L1 and store that into L3. So I did the log of L1 and store into L3. Now if you hit the stat, I did it again. If you hit the stat button and then edit, you'll see L1 looks like this, L2 looks like this, and then L3 is going to be the log of L1, and I'll have all that data here. Now we're actually going to graph it. So what I need you to press is second stat plot. It's under your screen. I'll show you. What you see here That right there is your stat plot button. So I hit second, then that button right there, and this right here is what I want to select. So select that one. I just hit enter. I want to make sure it's on. The type is the dots, little dots. My X list is going to be L1, but my Y list has to be L3. You may have to select that. And my mark is a dot. All right, so hit enter on that. Once you're done with that, oh, for goodness sakes, you're actually going to hit second quit at this point. And then find the zoom button and then hit the number 9. And that's called a zoom, well, what is it exactly called? Zoom stat. Looks pretty linear, doesn't it? Right? So we plotted it and it looks linear, therefore, so when it looks linear, therefore an exponential model should be a good fit. Look, we kept everything in here. Okay, this is the solution the book gave, where they actually calculated log y. They physically plotted them all. It looked pretty linear, so they thought exponential model would be a good fit. So we did all that work. Now we actually have to finish the problem, and the problem said find an exponential model, y equals a b to the x. By choosing 2 points, let's just choose 1, 2.48. And that right there is log y. And let's do the end, the beginning and the end, 4.56. So that right there is log y. Use these points to write an equation of the line, then solve for y. So let's see, we have y equals, let's do the slope, point slope form. So we just have y equals, y minus 2.48 equals m. I didn't calculate m, did I? 4.56 minus 2.48 over 7 minus 1. 2.48 divided by 6. Nope. Sorry, I messed that up. Divide by 6. 0.347. X minus, let's see, I used 2.48, so I have to use 1. Now, because we're using log y, this actually should be a log y. Oops, not sure what kind of English I'm writing there. Cool, so let's solve this thing. Log y equals sorry, I'm skipping steps, I shouldn't do that. 0.347 x minus 0.347, I just distributed. Now add 2.48 to both sides. So I get log y equals 0.347x. Let's see, plus 2.48 plus 2.48 minus 0.347, 2.13. This right here is a base E. Actually, I'm going to take this right here and start over on a new page. Y equals 0.347x plus 2.13. Remember, we're trying to find, sorry, it's log y, exponential function. So that's really log base e of y. That means that I can change it up to e raised to the point, I'm going to say 0.35, x plus 2.13 equals y. We dealt with this a few sections ago, but let's remember when I add the exponent, that means I'm multiplying, 35x times e to the 2.13, which really is e to the 0.35 raised to the x, e to the 2.13. I can calculate a lot of that. E raised to the 0.35 is e, oh, not e, sorry, 1.41 to the x. E raised to the 2.13 is 8.41. Let's write it in the correct formula, correct format. A, b to the x. Wow, that was a lot of work. All right, exponential regression. Calculator is going to do it for us this time. Using a graphing calculator to find a graphing calculator that performs exponential regression uses all the original data to find the best fitting model. And that's what we're going to do now. Use a graphing calculator to find an exponential model for the data in example 2. Predict the number of scooters sold in the 8th year. We already have L1 and L2. This is my X information, that's my Y. Let's keep it like that, okay? Now we want to do stat, hit the stat button, and the calc button, and arrow down. I'll tell you what number it is. To EXPREG, which is number 00. We can just arrow down and highlight it and hit enter. Make sure our X list is L1, our Y list is L2, our screen doesn't look like that. I'll show you what our screen looks like in a second. So that's what our list looks like. I can show you, right in this spot right here, a way to store your equation into Y1 if you ask me. Okay, I'm not going to put it in the video. It's just a shortcut. But at that point you want to hit calculate. And it's going to spit out y equals a times b caret x, where a equals a number and b equals a number, which this right here is exactly what we got on example 2, right? Now we can find the 8th year by substituting x equals 8 into our equation. 8.46 times 1.41 raised to the 8. And I got y at 138.9 scooters, or approximately 140. All right, we're not going to do all of these. We're going to practice maybe 2 of them. I probably should have put them on separate pages, so I'll have to pause and go back. But if you remember, we're going to grab both these points. 6 equals a times b to the 1, and 24 equals a times b to the 3rd power. So let's take one of these and solve for a. I'm going to say a equals 6 over b and plug it into this one. 24 equals 6 over b times b cubed. That simplifies to 6b squared. Divide both sides by b, I get 4 equals, divide both sides by 6. 4b squared, therefore b equals 2. Fantastic. Going back up here, a equals 6 over 2, 3. So y equals a times b to the x. Okay, I'm going to try one more. xy, so 8 equals a times b to the second, and 32 equals a times b to the third. A equals 8 over b squared, goes in here. 32 equals 8 over b squared times b cubed. So 32 equals 8b, or b equals 32 divided by 8 is 4. Okay, plug that back in. A equals 8 over 16, or 1/2. So y equals a times b to the x. Perfect. What if, in examples 2 and 3, how would the exponential models change if the scooter sales were shown in the table below? I'm going to go ahead and do a exponential regression. Okay? I just did the exponential regression, which you might want to practice. So y equals a times b to the x, where a equals 11.39 and b equals 1.45. So our growth rate is that, and then our initial amount. Okay, writing power functions. Recall that a power function has the form y equals a x to the b. Because there are only two constants, a and b, only 2 points are needed to determine a power curve through the points. I only have 2 constants, therefore I need 2 points to figure it out, right? So our first practice, write a power function y equals ax to the b whose graph passes through those 2 points. So first of all, let's substitute them just like we did in the past. 2 equals a times 3 to the b, and 9 equals a times 6 to the b. So I've substituted all I know. Let's solve for a in the initial equation. So a equals 2 over 3 to the b, which I know is silly, right? Let's substitute that in for here. 9 equals 2 over 3 to the b times 6 to the b. Ooh. That right there simplifies to 2, 6 to the b over 3 to the b. Simplify this right here. 2 times 2 to the b. Divide both sides by 2. 4.5 equals 2 to the b. Now we're going to do the natural log, the log log. So I'm going to change that from exponential into log form. So log base 2 of 4.5 equals b, right? I can actually calculate that. Log 4.5 divided by log 2. So use your change of base, which everyone's doing it different. I get b equals 2.17. Cool. Almost done. So I know that a equals 2 over 3 to the 2.17. Just use my calculator. I have a is 0.1 0.184. So I've got an equation. Y equals 0.184 times x to the 2.17. Golly, that's a lot of work. All right, I have 3 problems here. Actually, on a new page, I'm doing these 2. Cool? All right, let's try this one first. So we are writing a power function in this form. Y equals ax to the b. So I've got 2 points. Let's go ahead and substitute. Y equals a 2 to the b. Y equals a 7 to the b. Let's go ahead and solve these for a. Actually, we're going to just solve one of them. A equals 6 over 7 to the b. And let's plug that into that one. I don't know why. I just picked one, right? 6 over 7 to the b times 2 to the b. That gives me 6 times 2/7 to the b. Divide both sides by 6. This is exponential form. Let's go ahead and put that in logarithmic form. So log base 1/6 of 2/7 equals b. Handy dandy calculator. Log base 1/6 of 2/7 is 1.43. Go ahead and plug that into one of the other problems. Let's go ahead and do this. 1.43. I'm probably not the best one to pick. I'm just looking at that now. So I have 6 divide by 7 raised to the 1.43. I have a as, oops, that's an a, 0.371. So y, I'm sorry, my kids are so loud right now. 371 x raised to the 1.43. Okay, let's try one more and then we'll move on. All right, let's try this one. So we're putting it in the form y equals a times x to the b. Substitute. 4 equals a times 3 to the b. And 15 equals a times 6 to the b. A equals 15 over 6 to the b. That's not a b. 4 equals 15 over 6 to the b times 3 to the b. 15 times this together, 1/2 to the b. Okay, divide both sides by, nope, 15. Doing awesome here. I have, 4 divided by 15. Yikes. 0.267 equals 1/2 to the b. So change that into logarithmic form. Log base 1/2 of 0.267 equals b. Go ahead and calculate that. 0.267 divide by log 1/2. So here we have b equals 1.91. So we're going to take that and plug it back up into one of these equations. Doesn't matter. 15 equals a times 6 to the 1.91. I have 15. A, this right here, comes to 30.6. 15 divided by that answer. A is 0.489. So my equation is y equals 0.489 times x to the 1.91. Perfect. Awesome. Let's move on. All right, moving on. Transforming power data. A set of more than 2 points, x, y, fits into a power pattern if and only if the set of transformed points, log x, log y, fits a linear pattern. So if this looks exponential, this looks linear. Okay, so that's how we're going to figure it out. Biology. The table shows the typical wingspans, x in feet, and the typical weights, y in pounds, for several types of birds. Draw a scatter plot of the data pairs log x, log y. Is a power model a good fit for these original data pairs, x, y? I'm not going to do that. I'm going to type this into list 1, this into list 2. Then I'm going to take the log of list 1 and plug it into list 3, and the log of list 2 and plug it into list store it into list 4. So why don't you go ahead and try that too? So here you'll see where I put in the x values and the y values, and I took the log of the x values, and L4 would be the log of the y values. And here I just did a scatter plot. Actually, ignore this. I actually did a linear regression. Well, I can't read that. But don't worry about that. If you just look at the dots are in a straight line. So because they're in a straight line, we know that it's a power model. Okay, so let's go ahead and find the model. So now we're going to use those points. Let's see. I'm going to use that. No, I don't want red. Point slope form. Okay, so I need some points. I want to choose 2 points on the line from the log part. So I'm going to go back to my stat edit and look at list 3. It doesn't matter what I pick. If I arrow down, I'm just going to pick the log of, well, which one do I want? If you look, a point that they gave us was 3.41 and 1.69. If I take the log of both of those, I get 1.227 and let's see, 0.525 for the 2 points, and we can use those. And then if I grab another one, let's grab the last one. So these were the given points. If I look at the given points, 2.128 and 2.775. If I take the log of those, I get, oh no, that is the log. 2.128 and 2.775. These values are different. So let me give you those right values from the original table, 8.4 and 16.03. So let's go ahead and use these points, and first I need to figure out my slope. So change in y, 2.775 minus 0.525 over change in x, 2.128 minus 1.227. So my slope is 2.50. Cool. All right, we have log y minus, pick one of those 2 points, 2.774, I had 775, equals m log x minus 2.128. You can't read that, and I've run out of room. All right, I'll rewrite it in a second. I've run out of room. Oh, for goodness sakes. I don't know what's going on. Hold on. All right, I need to add, first I need to distribute this. So So I have log y equals, nope, minus 2.775 equals 2.5 log x minus 2.5 times, that should be 2.128. 5.32. Now I add this to both sides. So log, how did I turn blue? 2.5 log x negative 5.32 plus 2.775. Okay, I need a new slide, so I'm going to move this to another slide. I'll be right back. Okay, I remember last time we did this. This is where it got just yucky in my mind. I mean, it's not a huge deal, but let's see, what can I do? If you remember, I can put this as an exponent, which is nice. Raised to the 2.5 minus 2.545. Let's see, what do I want to do now? I know I'm trying to solve for this, and it's not fun. Let's see. This is base E, this is base E. If I do E raised to all of this, that will equal y, right? This right here, okay, remember when these match, I can bring down x to the 2.5, but I still have this one to deal with. Okay, when those are minus, okay, that's where we are right now, equals y. Cool, we're all good. E to the negative 2.545, y 0.0785, x to the 2.5. Whew, that's really not a smiley face. It's like a wiggly face with sweat dripping off of my head. That's awful. That's tough. I mean, we're going to have to practice that one more time for our homework, but that's not fun. Moving on. Oh, we're good. Talk about that one. Power regression. Okay, now we're going to find out how to do it with a calculator. Graphing calculator. Glorious. Use a graphing calculator to find a power model for the data in example 5. So in list 3 and list 4, we have our log data. Okay, we don't want that. We want to look at list 1 and list 2. So go ahead and hit Stat, Calc, and our power regression, that's letter A, is our power, doesn't look like that, power regression, and hit enter. Now we want to do this with list 1 and list 2. So our X list is going to be list 1, our Y list will be list 2. So go ahead and change those if you need to. And then hit calculate. So I get y equals a x to the b, and a is 0.0442 and b is 2.87. So that gives me 0.0442 x to the 2.87 as our answer. Cool. Awesome. Make sure that's right. Oh, I forgot to finish the problem. Reread the problem. It says estimate the weight of a bird with a wingspan of 4.5 feet. So if you look at this data, the wingspan is x. So we're going to go ahead and plug that into x. 0.0442 times 4.5 raised to the 2.87. 4.5 caret 2.87, enter, times. I get 3.31. And that is the wingspan. No, that's the weight of the bird. 3.31 pounds, or hashtag, whichever you're going for. Good work. All right, we're going to try this, okay? It's good practice. I'm going to put that in X, put that in Y, and do my power. It's not how you type it. Power regression. I get y equals a, 397.6, x raised to the b, negative 0.639. Not too bad. Hey, we made it. Daily homework quiz. Hey guys, before you just fast forward, this stuff was hard, okay? But I know you can do it. All right, take your time doing the homework. Make sure you understand it, and I'll be there to help you along the way. Cool? Good work today. There's your other homework quiz. Nice job.